this is some work I've been doing, mostly driven by some frustrations I had at desk, and then a few other people have come along with other sort of related requirements, and it's to do with the parcel monitoring system, which originally looks like this. So we've got oh, can you see my mouse cursor, by the way, with this mode or not?
Yes.
Yep.
Okay. So up at the top here, we've got what a high throughput executed task execution looks like. We've got your workflow process. You send a task through the interchange, eventually ends up through some other stuff at a worker, and the result comes back. That's this red path. And then monitoring adds on some stuff. So there's a database, which is managed by this database manager process. There's a router process with a crazy number of queues between them that I'm slowly removing. And then that's on the submit host. And then we've got ZMQ and UDP to send messages from various places that eventually then end up in this database. And the core of the work I was doing, that I've done here, is dealing with this UDP connection, which comes from workers which are running tasks on a remote node. They send things like, what time did this start running? Every 10 seconds, how much CPU time have they used? Various things like that. And those will get sent as UDP packets over the network inside a cluster like this. And so Desk really liked this monitoring generally. Two problems that we had. Desk makes fairly heavy use of the work queue executor, and some other people use the thread executor. And this monitoring system wasn't implemented to work with those. It didn't need a lot to fix it up. And years ago, a Desk contribution was that they paid me to make that work with other executors, which they did. The other really ugly thing is that UDP is unreliable, but lots of the monitoring code assumes that it really is going to get reliable message delivery, which is basically driven by the database having SQL primary keys in it. So there's quite a bit of, it also kind of assumes that messages arrive in a particular order, and there's quite a bit of code that's trying to avoid, work around that not being true as well. So there's two things to think about. One is we could use a different protocol, and one is that we could make that code not so reliant on reliability, and they don't really conflict with each other. And what I've been working on is the first of those, using a different protocol. So one thing that was merged into master in, well, 2 years ago, almost exactly, was if you're using HTEX, high throughput executor, then we can use the existing results channel to send results back instead of UDP. And that basically makes results as reliable as, makes the monitoring data as roughly as reliable as your results, which is to some extent 100% reliable. That only works with the high throughput executor though. I also implemented a prototype file system based thing, which makes one message per file. It works anywhere there's a shared file system. It's extremely reliable because your file system is also effectively 100% reliable, but it's got really bad performance characteristics because this is sort of a use case that is almost the exact opposite of what HPC file systems are written for. Another thing I'd like to try is ZMQ connections from the workers. In some cases, I've done a bit of playing around using multi-processing queues, but those only work if you are all forking on the same node and all from the root Python process, and in Parcel, that's kind of on its way out for other reasons. And of course, you might have an amazing solution for this as well that might go in here. And out of all of these, there's no clear winner that's valid in all circumstances. And so in Desk, we wanted to try different different implementations and different parameters and things, but there's not really any configuration structure in Parcel to experiment with this. It made experimenting with other users very hard because it involved source code modifications and things like that. But Parcel's answer to problems where there is no clear winner has traditionally been have some kind of plug-in API. Like you can plug in different executors, you can plug in launchers, whatever. So that's basically what I did. Was I looked at making a monitoring radio plugin. So that's a plugin that lets you replace this part of the architecture here with something else, with your own code, or with code that someone wrote for you. There's a couple of challenges that arose here that we haven't had with earlier plugins. So plugins are these stateful objects that live inside the submit side process. So you might have a high throughput executor object, or you might have a Slurm provider object. And they can sometimes have quite a lot of internal state with threads. And if they open dynamic ports, they remember which dynamic port they've opened, stuff like that. And in the case of monitoring, some of that state needs to end up on the worker side. For example, with UDP, how do you know which UDP port to send your result back to? It's this dynamically chosen UDP port that's chosen on the receiving side at startup time. And what that exact state is different depending on your radio protocol. So there's actually similar challenges when you start thinking of this as a problem. Then launchers in MPI mode HTEX, there's this sort of rival launcher mechanism in MPI mode HTEX. And the reason it exists as a rival implementation is in part because the launcher API doesn't let you send launcher configurations remotely. And the other part is that it doesn't have the methods that we need it to have. But in that case, we want to have a launcher, and that launcher runs in the process worker pool on a remote node. We've got what used to be our Outreachy summer project. We were thinking about how do you specify different worker selection algorithms. And in that case, the worker selection algorithm is running on, it is running on the submitting host, but in the interchange process, which is another process running next door to the main Python process. So there's still this notion of we want to configure it inside the workflow process, but send the configuration across to the interchange. And then Nishche came up with this the other week. We were talking about configuring logging, just regular Python logging in different circumstances in remote processes with a bit more of a richer interface than just debug mode on or off. And maybe there's something here that looks like that as well. The other challenge is that we have these stateful objects need to sort of start up and shut down in different places. So maybe we need a receiver that starts up if I've chosen a particular config, we need a receiver that starts up on the submit side to receive the messages. And that's got to be managed sort of distinctly from task execution. What happens right now is there are several receiver implementations, one for UDP, one for ZMQ, one for file system. And if you turn monitoring on, they all start up and they all use resources. So whichever one of these protocols you're using, you're still going to have the file system radio receiver code polling the shared file system, making file system load. We're going to have an open UDP socket, which is more of an attack surface. So we really only want those to start up for the radio modes you're using. So what I did was a prototype. I've been working on it for a few months, relatively slowly, along with a lot of tidying up, sort of monitoring code tidying up at the same time to try and make this a bit easier. And what I've ended up with, you can see in PR 3315. So there's 3 classes for each method that you specify now. You specify a configuration object called monitoring radio, and then that monitoring radio subclass, so you might call it UDP radio or ZMQ radio, that knows how to do 2 things. It knows how to start up a receiver and locally and start a receiver that can get data into the monitoring system, and it knows how to make a sender object that can run remotely on a worker. And so that gives the interfaces to set for the abstractions that I've encountered so far, for you to say, yeah, this is we need to start both ends of the connection together and being aware of each other. So that's what the architecture used to look like. What has happened now, if I go between the two, this monitoring router process is disappeared now. If you're using ZMQ, you can go pretty much straight to the database manager. You don't need to go through this router anymore, because all that router did was jumble stuff into different pipes, and they all got merged again over here. And then depending on, here are the radio senders that you might have configured. And depending on what they do, they might, like a ZMQ one, which I haven't written yet, might just send directly into the database manager over ZMQ. The HTEX one sends back over the results channel, and then the interchange uses ZMQ, which is that's the default for HTEX and has been for a couple of years. The old UDP one, it has to start up a receiver, and the shared file system one also has to start up a receiver. So you sort of end up with all of this. We've got, it says or several times here, right? You wouldn't be running, or it would be unlikely that you would have all of these configured in a single workflow. You would have whatever your favorite was, and you would just be using that. So only one receiver or no receivers at all. So it's a bit of the bit that troubles me the most is the initialization of all of this. It's kind of a delicate sequence. The user's got to specify a config, and then it's got, that config has to know how to start a receiver, but then starting the receiver might generate some more configuration state, like port numbers or working directories and things like that, those need to be known to the sender in order to be able to send a message back to the receiver. So we've got to start up a receiver, we generate some states, then that configuration state, which I'm a little unsure how I want to structure it, gets pickled and sent to the remote worker as part of a task. So that the existing UDP state gets pickled that way at the moment. And what this work does is changes that into an abstract class that is radio specific. And then on the remote worker, that configuration containing object knows how to send a message back to where it came from. So that kind of looks like what's happening now already, but with better API abstractions rather than being hard coded for specific radio types. And so path forwards for desk, I would like to experiment with more ZMQ stuff for work queue and taskvine, because otherwise we don't have a really good monitoring answer for that at the moment. I would hope over time maybe a favorite protocol evolves, maybe. I know Nishche is doing some work on a project called Chronolog that Kyle is somehow also involved in. And so the story there is we're going to help someone else solve this problem. We're going to use this tool Chronolog, which is a distributed logging system. We'll let that be the transport layer. So all we need to do, we just have to talk to the transport, talk to Chronolog as a transport layer. And that's basically one of Nishche's summer projects. And it's also a slightly more principled way to send monitoring messages somewhere else that is not the parcel monitoring database. So Desk occasionally wants this for their own. They have a next level up workflow system that submits into parcel. Sometimes they ask about, can we get monitoring data to go into that? And maybe if you were someone like Globus Compute, you might want to ingest this info, but into the Globus Compute cloud infrastructure rather than into a SQLite database that's living on an endpoint, for example. So this is another potential interface for a way that you would hook that stuff in, perhaps. Okay, so that's the end. That's what I've basically been working on, that I'm slowly merging towards getting merged into master as a way forward for some of my other monitoring work. Okay, does anyone have any questions?
Hey, Ben.
Yeah.
That was great. I have a couple of questions.
Yeah.
How does the initialization of the receiver happen? Is that when you initialize the monitoring radio class, or is that like a two-step process?
So what I've done is you've got a monitoring radio config object, and it's got a method that's called something like start receiver.
I see.
And you call that,
and it's idempotent. Like, I'm just thinking, like, can you share it with multiple executors?
I wasn't expecting it to be shared between multiple executors.
Okay.
Just because they're not super heavyweight.
Okay, it's lightweight enough that it doesn't really matter to duplicate that. Okay.
Yeah, like 3 executors means, all right, I'm going to open 3 ports to listen to my UDP messages, right? It's more than it does now, but it also removes any kind of sort of sharing. The code written right now is not architected to make that sharing super easy. Right.
Okay.
So
yeah,
it's a slight weakness. I do claim that it is slight.
Yeah. It's not a big issue. I just wanted to figure out, like, what is the expected mental model to work with? Like, everybody gets an independent one, or is there a possibility of sharing it? Is there any value?
Yeah, a lot of that move is sort of, well, you've got things like Globus Compute that just want to have high throughput executor without any DFK parcel management infrastructure around it, right? And that's sort of pushed me towards saying, well, right, we're going to make executors able to exist on their own. Right.
So, I guess that was going to be my follow-up question. So from the compute perspective, or a situation where, like, there is a managed receiver, essentially.
Yeah.
Have you considered like an HTTP radio? Like, just make a REST call. Would that?
I haven't, but it certainly fits in this architecture, right? The receiver would be a
That's
web.
What I thought.
Yeah, the receiver would be.
So as long as the workers can call out.
Yeah, right. I mean, it's all based on part of why there's no one good choice is because there's all these different circumstances.
Right.
Yeah. But if you were doing HTTP, I'm not sure that would be too different from the network characteristics of using ZMQ, for example. I'm not sure.
Right.
Yeah.
Right. I mean, like, the question there is just, can the workers can most likely reach the login nodes, because if that doesn't work, nothing works.
Yeah, right.
The question is, can they call out to the network is a different question.
Yeah, well, they don't have to, right? Yeah. They can send their messages to something running in the endpoint process. And we know the endpoint process, if it's Globus Compute, we know the endpoint process can reach the cloud by definition.
Yeah. Right. Yeah. So it's just that I was thinking that we might need a proxy at most.
Yeah, inside the endpoint. Yeah.
Okay, that's actually great. That works out very nicely then.
Yeah. What I had that in mind as a use case without actually trying to solve the problem, but trying to be careful to not put anything in the way architecturally that would stop it happening.
Right.
Yeah. Like, it seems like an obvious fit.
Yeah, I mean, that is probably a pretty good solve for the question of like the opacity that we have once a function starts running, like what is going on with it,
Right.
and you are a machines away.
Yeah. Yeah.
Okay. Cool. Yep.
Does anyone else have any questions?
So this isn't, I guess this isn't really a question, just, I guess, just kind of looking at the diagram, particularly at the end.
Mhm.
I guess I'm just trying to think about if this is actually simpler than what was there to begin with, or if it's just better functionality but more complicated. And
This diagram.
yeah,
So it's what's added is more
because you wouldn't really have the whole thing at once, so that's why it's
right.
a little bit.
You would kind of have something that still looks like this, but sort of like if you imagine this monitoring router process becoming this UDP process, right?
Yeah. Okay.
And then you would, I mean, you would lose this, you would lose that, and you would lose that and this, right? And you would lose this, and you would lose this, right? Now you're back to, we've just moved the box around on the screen.
Right. Okay.
Yeah.
Yeah. Okay. All right. That helps.
The specific point was not ready to change. This is really about adding configurability more than anything else. Is how do you configure that this is the box you've chosen and this is the sender you've chosen, which in the existing setup is, it was sort of written assuming parcel has chosen UDP for you.
Okay. Yeah. No, I think that's how that makes more sense now.
Yeah.